Hey everyone, I'm Sid, and today I'll be talking about Project Pointer. Project Pointer is a tool I've been working on that aims to make 3D interaction more intuitive and powerful. It's a smartphone app that works in conjunction with a paired desktop app. It's used for CAD, gaming, and 3D modeling applications, but theoretically can be used for any sort of 3D interaction. I've developed a number of example apps that illustrate the capabilities of Project Pointer. I'm really excited to show one of them to you today. This companion app allows us to place multiple 3D models in order to build up an overall scene. It can be used in game development to build an environment for the player to interact with, or perhaps by a real estate developer who wants to illustrate a proposed site plan. Let's take a look at it in action. So on the main screen we have the desktop application view, and in the bottom right we have the view from the smartphone pointer. What we're going to do here is build a simple little scene that illustrates some of the interactions that are possible with the Project Pointer app. So the first thing we're going to have to do is pick up the phone and calibrate it by pointing it at the indicator marker in the bottom left. That's sort of a signpost that tells the computer vision where the overall screen is. So we'll go ahead and try to calibrate it by hovering over the indicator, and okay, we can see that it's recognized where the smartphone's location is. Now we can point the smartphone at the screen as a sort of 3D cursor. We can see that the object is going to where the smartphone is pointing at, and in order to place it, we just tap and release. That white box is an indicator showing where I'm touching the smartphone's touchscreen. Now that's great. We've placed down a little well in the scene. Let's pick a different object, like a tree. We can put down some trees in order to further decorate the screen. Oops, that was weird. So we'll go ahead and tap, place that, make a little couple of happy little trees here. And okay, that one was a little tricky. And there we go. That looks pretty nice. Looks like we're on our way. But let's put something else in here, such as maybe some walls. Now here's a problem. This wall isn't facing the way I want it to face, but we can rotate it by swiping left and right on the screen. As you can see, if I swipe, and as I swipe, the fence turns around until we can get it in the position we want and go ahead and place it the same as before. Okay, there we go. Let's place them in a line and turn this one the way we want to fit with the terrain. And okay, I'm happy with, wait, hang on. Okay, I'm happy with that. Now let's add a building in there. We'll go ahead and select it using the button. Once again, we're going to go ahead and rotate it into the position we want. And there we go. We're just going to precisely put it where we want it to go. All right, and the scene's looking pretty good. Maybe some last touches, put some rocks lying around. And finally, some trees. So this is a sort of workflow I've done a lot, both as a hobbyist game developer and in some of the classes I've had to take where I'm working in CAD applications. And it's really intuitive and easy to place objects in this scene because you're simply pointing at where they want to go and using the smartphone to give your input. So let's take a look at how this works internally. I've divided the app into a couple of different components. First, we have the input. We get camera input, which tells us where the smartphone is and what it's pointing at. And of course, we have multi-touch input, which gets the gestures that the user inputs into the touchscreen and uses that to control the app. Those inputs are relayed to a networking module on the smartphone app, which relays that information to the companion desktop app, which then processes that input in order to run the overall application. So let's start by taking a look at how we get the input. In order to get the positional data, we used computer vision using the Vuforia AR package. It processes the camera input to determine where the computer is relative to the smartphone. Vuforia provides a tool that allows us to determine the location of a specified marker image, which you saw in the bottom left of the demo screen. We had the phone scan that image to determine where it was relative to that image, in turn telling it where it is relative to the computer. Once we've done that, the phone can use its overall camera feed to determine how much it's moving relative to that initial position, minimizing the need to have more markers taking up that valuable screen real estate. As for getting the multi-touch input, that's fairly standard data processing. We just look at the position of the phone, where the phone is tapped, and based on that data, classify the gestures into swipes, taps, pinches, and other standard gestures. Now, once we have that input, we need to send it to the desktop app. That's where the networking comes in. And that's the most critical aspect of this project. People, when they use controllers, they really don't have a very high tolerance for delays because the types of controllers people are familiar with don't have very much delay. When you use a keyboard or a mouse, you're not expecting to wait after you provide an input. So in order to meet that expectation, I really tried my best to minimize the latency. The internal application logic is structured in a way that minimizes the need for sending data overall. And for the data that I am sending, I'm using UDP. Another way we minimize the amount of data that needs to be transferred is by doing as much input processing as possible on the phone. So for example, in terms of the positional data, we're getting updates every single frame from the camera. But we don't need to send every single one of those updates to the desktop. We can collect and aggregate the data over multiple frames and then send one message over a longer period of time in order to reduce the overall latency. In terms of the messages that are getting sent, we have really two types. We have positional data like camera input, as I mentioned, and other gestures like swiping and pinching that occur over a period of time, whereas commands like button presses are sort of a one and done type deal. You push the button and that message needs to get sent. So these command type messages require more reliability. When a user pushes a button, they really do expect that to respond, and they won't tolerate it if that packet that's containing that data gets dropped, for example. However, for positional data, that needs to be fast because people are intuitively good at understanding movement and they can really easily sense when lag occurs, but they don't mind too much if a couple of packets in between are dropped because we can sort of smooth that over with post-processing on the desktop app. So because of that, I essentially had my networking protocol set up to send commands with an acknowledgement in order to ensure reliability while sending positional data without an acknowledgement. And in the testing data that I'm showing here, acknowledging only commands but not acknowledging positional data resulted in a reasonably low overall delay while not having the unacceptable scenario where we're dropping critical commands, such as buttons being pressed. So those are the hard numbers, but an equally critical part of the user experience is the more subjective area of how the companion apps were developed. I aimed to demonstrate both the productivity and entertainment uses of Project Pointer, such as with the sample app that I showed, and in addition, I developed other apps such as a first-person shooter and a voxel-based 3D modeling application. All these apps are tailored to work with the Pointer app, which means, for example, among other things, they have large buttons that are easy to press using the pointer. And in general, they acknowledge the fact that certain interactions are easier or harder using the pointer. Some interactions, based on my very limited user testing, that are easier with the pointer are aiming. You simply point your smartphone at an object in the space, which is very intuitive. Manipulating objects using gestures such as swiping left or right is also pretty easy to understand. And overall, there's a lower learning curve. It's not quite as intimidating for new users as a keyboard and mouse, which can have millions of different possible command combinations. However, it is limited in a couple of ways. As you saw when I was demoing the application earlier, it can be hard to do precise interactions, I struggle to place that one tree between two of the others, and very fast movements can cause errors in the computer vision processing, which can cause the smartphone to lose track of its position, requiring the user to scan the marker in order to recalibrate their location. So with all that in mind, here are some of my thoughts on where I can go from here. Based on, again, that limited user testing, the Pointer app is very interesting to new users and it's very intuitive. It's sort of cool that you can use a phone to interact with your computer, sort of point at something that's within the computer itself. However, it's also not ideal for use in professional contexts. It's not really great for CAD, where you're doing really precise designs and have to make really complex shapes that currently can't be achieved with the Pointer app. And as such, maybe this app is best suited for educational purposes. It can provide a really fun and inviting first experience with 3D applications like CAD and modeling for new users, and it's also, I think, viable as an overall entertainment tool. In terms of next steps, I'm going to try to incrementally improve the user experience and continue to reduce latency in the networking. Currently, my networking is only set up to send commands from the smartphone pointer to the desktop app. However, if I implement sort of a two-way networking system where the desktop app can send commands back to the pointer, that could enable some really good contextual input, like you could open a contextual menu, have different sort of modes of user interaction based on what objects you have selected. And this has a lot of potential, but on the other hand, I need to be able to implement that without increasing the latency by an unacceptable amount. And finally, and I think this is most important, I really want to expand on what the companion apps are doing. They're what demonstrates the potential of Project Pointer more than anything else. So I really want to do the best I can to develop companion apps that show the unique modes of user interaction that are possible with Project Pointer. Thank you all for listening.